Hello, calculus class people. Hope everyone is having a fantastic day. Today we are going to be talking about our chain rule for derivatives. So a little background on where the chain rule came from. It comes from the same idea that composite functions come from. Composite functions, if you remember, is like f of g, where f represents the outside function and g represents the inside function, right? So g goes inside of f. So just as a little reminder of something here, if you wanted to find f of g, let's say that g is 2x plus 3 and f is the square root of x. If you wanted to find f of g, that means that g goes inside of f, right? So we're looking at f parentheses g of x. So we take g of x and put it inside f of x. So we're going to take all this and put it into here. This is going to give us the square root of 2x plus 3. So those are what we call composite functions. Now the problem comes as to when we have to take the when we have to take the derivative of a composite function. And when that happens, we use what we call the chain rule. The chain rule. Think of these as linking individual pieces together. So here's how the chain rule works. Remember, your product rule happens if you're multiplying two equations together, two functions together. Your quotient rule happens if you are dividing. Well, this is what happens if you have composites. So if the derivatives of g of x and f of x both exist, and f, capital F, is f of g, is the composite defined by cap f of x equals f of g of x, then what this is saying, if g and f are both differentiable and you use a composite function, then the derivative of capital F of x, the derivative of a composite, is the derivative of the outside with the inside still intact times the derivative of the inside. So it's the derivative of the outer defined at the inner, derivative of the inner. Okay? So it's derivative of the outside times the derivative of the inside. Now when we do the derivative of the outside, the inside stays the same. Okay? So to help out with this, here's how we're going to look at it. Now, I think after a couple of these, hopefully this should make some pretty decent sense. Here's how we're going to look at this. For y equals 2x plus 1 to the fifth power, the outside of this is the fifth power, right? The outside of it is the fifth power. The inside of it is the 2x plus 1. So here's what this looks like then. If you've got the derivative here, so you've got y prime is equal to, and it's the derivative of the outside. So if I was just to take the derivative of this, drop your 5, and then take 1 power away, it would be 5 parentheses the 4. The inside stays the same, so the inside is 2x plus 1. See, the inside is g of x, it just stays the same. And then times the derivative of the inside, which is 2x plus 1, so the derivative of this is 2. That's the chain rule. And then you can simplify it by saying 5 times 2 is 10, parentheses, 2x plus 1 to the fourth. Now the reason why this is the best way to do this, we'll call that 3 steps. I had to write down the outer, write down the inner, and then plug into my equation. 4 steps if you simplify. Could you imagine taking 2x plus 1 and multiplying it out, 2x plus 1, 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 to get a 5th degree polynomial just to take the derivative? There ain't no way. There's got to be an easier way. This is that. Okay? So again, it's the derivative of the outside with the inside still the same times the derivative of the inside. Okay? y equals to 1 over x to the square root of x squared plus 1. Okay, I'm going to do something here because right now this is a quotient rule. I'm going to do something to try and simplify this. The first thing I'm going to do is I'm going to see, can I raise all this up to get rid of this fraction stuff that's happening right here? If that's ever the case, I want to take that route. And here we can. This is going to be x squared plus 1 to the negative 1/2 power, right? X squared plus 1 to the 1/2 is in the denominator, so we make it negative and it draws it up top. So that just made my problem a lot more, or a lot less complicated, a lot more simplistic, because my outside now is a negative 1/2. My inside is x squared plus 1. So y prime, I've got my outside. I'm going to take the derivative of my outside, which is going to be negative 1/2 parentheses to the negative 3/2. We subtract 1 away from our power. Inside is still the same, times the derivative of the inside, times 2x. All right, simplify it here. Y prime is equal to, negative 1/2 and 2. That's just going to be a negative x. And then if I drop this down to the bottom here, let's say this simplifies to negative x over x squared plus 1 to the 3/2 power. All right, so if you got lost on that little step right here on simplifying, drop the power to the bottom. So now this is negative 1/2 times 2x is negative 1x is what's left in the top. And x squared plus 1 to the 3/2 is now on the bottom. So drop your negative power, simplify what's left. Okay? And that's pretty much the gist of it. So here's how I would approach every single one of these problems. When I'm looking at one of these problems, the very first thing I do is identify what your two different functions are, the outside and the inside. Okay? After you identify the outside and the inside, it gets pretty simple here. It's the derivative of the outside, with the inside still the same, times the derivative of the inside. Okay? Let's go to the back and let's try some here. Now, if things weren't complicated enough. Example 1. First thing I would do on this is change your square root. Let's change that to f of x is x squared times 9 minus x squared to the 1/2 power. Okay. Now this is where derivatives get slightly combobulated. So I want to make sure that we go slow and that we stay on point with this. Looking at f of x, there are two rules I see popping out at me. I've got a product rule because I'm multiplying x squared in this guy. I've got a chain rule because I've got an outside function to the 1/2 and an inside function, 9 minus x squared. So I have a product and a chain rule. So again, first thing, after we simplified a little bit, the very first thing is to identify what rules are we using. I'm using a product rule and I'm using a chain rule. Now, by writing that down, it helps me to go back and look at my work and make sure I did a product rule and a chain rule. Okay? All right, so let's figure something out here. Let's start with the chain rule first, because to do the product rule, I need this times the derivative of this. So let's figure this out. For our chain, I've got the inside, which is, or excuse me, I'm sorry, I'm supposed to start with the outside. I'm sitting here trying to get ahead of myself again. I've got the outside, which is parentheses 1/2 I've got the inside, which is 9 minus x squared. Okay, so your derivative then, is going to be the derivative of the outside, 1/2 times a 9x squared to the negative 1/2. Remember, it's the outside with the inside still the same, times the derivative of the inside, which is a negative 2x. Okay? Now we can simplify this just like I did on the other one. I can simplify the negative 2 and the 1/2 here. That'll just give me a negative x, and then bring what's inside the negative exponent to the bottom. So what I'm left with is a negative x over 9 minus x squared to the 1/2 power. Okay? Or if you wanted to, you can write it as negative x, the square root of 9 minus x squared. Okay, either one of those will work. It may be a little bit easier square rooting wise, but we'll cross that bridge when we get there, okay? Okay, so here's my chain rule. Right? I've done the chain rule. Now I'm going to do my product rule. So my derivative, f prime of x, my product rule is the first times the derivative of the second plus the second times the derivative of the first. So first is going to be x squared times the derivative of the second. Now, since the original problem gave me a square root of 9 minus x squared, let's go ahead and plug in the square root over here, this one. If we use this one, we'll have to go back and use this power of 1/2 as well. That might be a little iffy with simplifying. So let's just use square roots for right now. Let's use this guy over here. And again, I'm doing that because the original problem started with a square root, and now I'm going to have to plug back in. See, on the front page, it didn't matter because I wasn't doing a product rule. Now I am, so just to see if I can make it a little neater, I'm going to use the square root. So times the derivative of the second is negative x over the square root 9 minus x squared plus the second, which is the square root of 9 minus x squared, times the derivative of the first. The first is 2x. Right? So again, you've got first, second. Okay, so to find the derivative of the second, we had to use the chain rule. So it's kind of like we're compounding rules here. We're using different rules on the same questions, really. All right? Now, from here, we can simplify this a little bit. On the f prime of x, if we multiply x squared and negative x, we get a negative x cubed over 9 minus x squared with a square root over it. And then plus, we got 2x square root of 9 minus x squared. Now again here. If we wanted to keep going and simplify, we can. I'm going to show you how to do this. But if this was on the free response and all I was asking you to do was find the slope of a tangent line, then you could stop here, plug in your x values, and just chug, like plug and chug. But because I want to show you how to simplify, I'm going to keep going for some of the multiple choice questions, okay? So we're adding two things that are not alike. We've got a fraction and not a fraction. Well, let's make this a fraction over 1. And what does it take to add fractions together? It takes a common denominator, doesn't it? So I'm going to multiply the top and the bottom by the square root of 9 minus x squared. I'm going to multiply the top and the bottom by this denominator to make it the same. And you'll be surprised how much more simplistic this actually makes our job. So this is going to be negative x cubed. Now when I multiply this guy here, what's going to happen to these, to a square root times a square root? It's just going to go away. So isn't that plus a 2x times 9 minus x squared? Look at that for a second before I do your denominator. Again, 2 times x times the square root times the square root. Your square roots are the same, so a square root squared is just going to be what's inside, 9 minus x squared. So we can just drop the square root there, and we're all over square root of 9 minus x squared. And then just simplify a little bit. We've got 2x times 9 is 18x. 2x times a negative x squared is negative 2x cubed. So let's simplify. We'll have a negative 2x cubed and a negative 1x cubed. Well, that's a negative 3x cubed. 2x times 9, so plus 18x. I will not make light of these. These questions are some of the more difficult ones, mainly because there are just multiple different places where you might get lost. Just remember, big picture ideas, okay? Bigger picture. It's a bigger picture. Big picture ideas is a product rule and a chain rule. First, d second plus second d first. To find the derivative of that second, though, I had to do a chain rule. So once I did my chain rule, the rest of it was just piece of cake. It was all product rule and algebra. So the only thing different here is that you may have to, at some point, do a chain rule. Okay? Let's do this. On example number 2. Now there are two methods. Oh, it's raining outside. There are two methods to doing example number 2. I'm going to tell you both, and I'm going to do only one of them. The first method to doing example number 2 is to set it up as a quotient rule, and on the bottom here, a chain rule. The other option would be to change this, because it's a pretty simple denominator. We could change that 3 to a negative, move it up top, and do another product rule. But since we already did a product rule up here, I'm going to use the chain rule on this one, just to show you how to do it. But remember, if you get stuck on something like this and you know that you know how to do the product rule, then what I would do is make that 3 into a negative, move it up top, and then work it the same way I did this one. But since I've already done it one way, remember I told you there's usually more than one way you can do these. Since I've already done it one way, I'm going to use the quotient rule down here, just so you can get a good idea of how to use that. Okay? So the first thing I'm going to do, just to make my life easy, because the quotient rule says bottom d top minus top d bottom. I know that d bottom is going to be a kicker. So I'm going to set up my chain rule first, okay? Let's set up the chain rule for the bottom. Chain, we've got outside, inside, and derivative. So the outside is parentheses 3. The inside is x squared plus 2. The derivative is the derivative of the outside, x squared plus 2, still on the inside there, times the derivative of the inside, 2x, which is 6x times x squared plus 2 squared. Right? This derivative simplifies to 6x, x squared plus 2x. Okay. So when I go to do my chain or my quotient rule now, when it's bottom D top minus top D bottom, that D bottom is going to be this guy right here. Okay? F prime of x is bottom x squared plus 2 cubed times the derivative of the top, which is 1, minus the top times the derivative of the bottom. That's this guy down here. 6x x squared plus 2 squared all over bottom squared. Okay, be careful how you write that. Pause here. Get a second to catch up. Pause the video, all right, if you need to catch up. So apart from this being a chain rule, this is something we've done before. It's just a quotient rule. So apart from having to use the chain rule, it's just a regular quotient rule. Okay? Let's simplify this out a little bit here. F prime of x is going to be equal to, this times 1 is just going to be x squared plus 2 cubed. And then minus, we've got an x times 6x. That'll be 6x squared times x squared plus 2 squared all over x squared plus 2. Now on the powers down here, we've got 3 to the power of 2, so multiply together and you get 6. Okay? This seems complicated. Again, if it's free response and you're just finding a slope of a tangent line, stop here, plug in x. But if it's a multiple choice and you need to simplify more, keep going. Now what do these all have in common? Look at this. What do they all have in common? Every one of these terms, this guy, all this right here, and this guy, all have x squared plus 2 in common. We've got 3 of them here, 2 of them here, and 6 of them here. So can we take out 2 of them? Make life a little easier on us? Let's do that. Let's take out 2 of these guys. Here's what's going to be. F prime of x squared plus 2, equals x squared plus 2 squared. I am going to take out 2 of these guys from the top. What is this going to be here? It's going to be, if I took 2 of them away, it'll be x squared plus 2. Just one of them now, right? Minus 6x squared. And if I took these 2 away, it's just that. And then in the bottom, let's say we've got x squared plus 2. This was to the 6th, right? So what this allows us to do now, these 2 can cancel out with 2 right here. Leave me with a power of 4. And now I can just simplify. F prime of x equals, there's nothing in front of the parentheses, so let's get rid of them. What's x squared minus 6x squared? Well, that's negative 5x squared plus 2 over x squared plus 2 to the 4th. So I want to make sure and point out here, the only thing new that we are adding to this is none of this. It's only the fact that we had to use a chain rule when we said bottom d top minus top d bottom. When we did the derivative of the bottom, we had to have a chain rule. That's the only thing new that's coming in with this lesson, okay? I really want to make sure and drive that point home, that that is the only thing that's new here. This is just algebra. All right? So remember, on the calculus test, you're being judged on your calculus, not your algebra. But if it's a multiple choice question and it comes down here to this and simplifies, you got to know how to simplify. All right? Let's call it a day.